Hi, my name is John Trowbridge. I'm the principal investigator for the Ocean Observatories Initiative, funded by the National Science Foundation. And today I'll be giving a brief overview of the OOI program. Next slide, please. The vision for the Ocean Observatories is established through an extensive planning effort. It's a science-driven ocean observing network delivering real-time data from more than 800 multidisciplinary instruments to address a number of critical science questions that have been raised about the ocean and Earth system. The data are freely available online, and the envisioned lifetime of the program is 25 years. The map shows, if you back up, Darlene. The map shows the OOI arrays beginning in the Pacific. There's the Station Papa array at full ocean depth, sampling from seafloor to sea surface in the Gulf of Alaska. The regional cable array, which comes out from Oregon and Washington across the shelf and slope out onto the continental plate offshore the Northwest US. The coastal endurance array on the same shelf and upper slope. Moving to the Atlantic, the global Erminger Sea array just off Greenland. The coastal Pioneer array off New England. Those are the arrays that are maintained currently by the OOI. The two Southern Hemisphere arrays were occupied for several years. They are no longer occupied by the OOI, but we continue to serve data from those sites. And the basic idea is that data are collected from these different sites, served through a common cyber infrastructure to everyone on the World Wide Web. Next slide, please. The OOI is one of about 30 NSF large facilities, a significant investment by the National Science Foundation. It was established over many years. As I said earlier, there was more than 10 years of community-wide planning to set the program in place and establish the funding. Construction and initial operation began in 2016. Back up, please. Commissioning happened in 2016. This was a formal process by the National Science Foundation. The second phase of the program, operation and management, began in October 2018, 2 years ago. And this is a partnership between the Woods Hole Oceanographic Institution, University of Washington, Oregon State University, and Rutgers. And to date, we've been serving data for a few years now following commissioning, and researchers and educators worldwide use OOI data for scientific analyses, for scientific publications, and also in classroom education. You can see the image on the right is the deck of the ship in preparation for a seagoing operation. And you can see the amount of infrastructure that's involved. Next slide, please. I'll describe the infrastructure in a little bit of detail. This is the regional cable array off Washington and Oregon. There's a site at Pacific City where the cable exits shore. There are two branches to the cable, one going nearly directly offshore and crossing to the axial seamount array, where a significant amount of research has already been accomplished with some very exciting results. Then there's a south cable line that goes out a short distance and then comes back up the shelf and slope and continues on into the cable portion of the Pioneer array with some very different science questions that are enabled by this infrastructure. Next slide, please. The coastal endurance array occupies the same general area as the regional cable array, and I'm showing here a cross section instead of a map so you can get an idea of the water column coverage. This is one of two lines. This one is the Newport, Oregon line, which is south of the Columbia River. The other line is off Washington, is north of the Columbia River. So the two lines bracket the Columbia outflow, which is one of the major oceanographic features of the region. And you can see here that the array consists of moorings and gliders that span the water column and span the array. And in this particular case with the Newport line, the cable array is made use of so that high power and high bandwidth are provided to some of these sensors. And this array occupies the inshore at about 25 meters, the shelf at about 80 meters, and then the upper slope at about 600 meters. Next slide, please. The other coastal array is the coastal Pioneer array, which is off New England, just south of Martha's Vineyard. And this array was set up in a different way, in contrast to the endurance array, which is planned to endure for 25 years, the Pioneer Array is planned to move to different places after periods of 5 to 7 years in a particular place. So the initial design was to understand shelf slope exchange processes and associated biological and chemical processes at this important site, which has a very rich fishing ground. And so the concept is a little bit different. It's instrumenting essentially a box and using an array of moorings, gliders, and autonomous underwater vehicles to quantify the air-sea fluxes across the air-sea interface and the structure throughout the water column. Next slide, please. The global arrays have a common design. This shows the Erminger Sea Array, which is about 2,800 meters. The others are in about 4,000. And these are all similar. There's a surface mooring and a profiling mooring to provide seafloor to sea surface coverage throughout the water column at one site. There are flanking moorings at 2 related sites to give some information about lateral variability. And there are gliders that transit the arrays to provide sampling in the upper 1,000 meters of the water column, and also to communicate data back from some of the subsurface assets. Next slide, please. All right, all of these arrays that I've described produce a diverse and very deep collection of data. There are 89 platforms, 830 instruments, and there are more than 30 different types of instruments. So this is a very interdisciplinary array of sensors. There has been a lot of data collected. There are lots of data download requests every month from users at a variety of different places. And a large amount of data is downloaded every single month. These time series data can be used to look at short-term processes, for example, passage of a hurricane or response to eruption in a cable array, for example, or some other short-term event, but they can also be used for long-term process studies to build up statistics and understand processes like response to El Nino or hypoxic events. And these data can also be used for much longer term studies extending over decades. And that would be relevant, for example, in the Erminger Sea, a site of convection, which is important for the deep ocean circulation. There is the opportunity for people not engaged directly with the program to add instruments. There's a process you can check out on the OOI website if you're interested in adding an instrument. And all in all, these data are advancing our knowledge of a number of different processes that are identified in the early planning stages. And I've listed some of them here: climate variability, the carbon cycle, global and plate tectonics, biogeochemical cycles, ocean food webs. Next slide, please. So we track scientific output from this array pretty closely, and we keep track of publications and we list them on the OOI website. So if you're interested in what's been learned so far in more detail, you can always go there. But I've highlighted just a few publications here. And I've highlighted a number that are in relatively high profile journals, Nature and Science. There are lots of publications in others that are equally worthy, but I'm just focusing on these to give you an idea what's been learned from the various arrays. The very first one, there have been some really interesting papers written so far about what's happening with ocean convection, looking at the Erminger Sea site, in particular, combining the OOI data with other data streams that are available. And there actually has been a series of papers on what warming and what the freshening fresh outflow from the Arctic might mean in terms for ocean convection. The second one has to do with a new mechanism for triggering of earthquakes. This is based on data from the regional cable array observation of earthquakes and the various processes that are happening there. The third one has to do with low salinity pulses off the central Oregon coast. This is an interesting observation. Has to do with a lot of processes out there, warm blobs, hypoxia, and so on, these anomalous water masses that we can now observe with this array of assets in the Endurance Array. There's a new understanding of shelf slope exchange south of New England at the shelf break based on measurements at the Pioneer Array. The big story there is the Gulf Stream. It has changed its behavior in the last couple of decades, and that's picked up by the Pioneer Array. and helped identify new mechanisms for slope exchange in that important region. And then the final one, there was an eruption that was observed at axial seamount, and that was very exciting and produced a number of high-profile papers. And one of the most interesting things to me as a non-geologist is that the groups that are working on this are in the position to predict when the next eruption will occur based on the set of OOI assets in that region. So this is a exciting and, in my experience, rare example in earth science when you can actually make a quantifiable and testable prediction based on these data. As I said before, you can look at these publications and many others at the OOI website. Next slide, please. All right, OOI data are being used in the classroom. Education is not specifically part of our mission as operators of the OOI arrays, but we do try to enable educational use and interact with the many fine educators who are interested in using the OOI data. And I'm just highlighting a very significant effort here at Rutgers University in New Jersey. This is called Ocean Data Labs. And this is a great program funded by National Science Foundation, where they've targeted undergraduate oceanography courses and put together information that can be used in courses and also put together training for educators to use OOI data in their classroom education activities. And there are a number of different things happening here. There are data nuggets that can be explored by researchers and educators and students, data explorations that are made possible. There's a lab field manual, and I believe that this is a tremendous resource for both professors and students. Next slide, please. A recent accomplishment of the OOI was launch of a new user interface for accessing data. It's called Data Explorer, and I welcome everyone to try it out if you're interested. With this facility, you can search and download all of the data, cabled, uncabled, and you can look at a variety of different interdisciplinary processes. You can compare data sets across regions and disciplines. You can generate and share custom views, and you can also download full data sets. Next slide, please. All right, that's the end of my presentation today. And thank you again for attending. And if there are any questions, I'll be happy to try to answer them. All right, I'm not seeing any questions yet. And I'll just stay on the line for a short bit longer in case anyone is interested in asking questions. What is a data nugget? A data nugget, I believe this is an Ocean Data Labs creation. And my understanding is that this is a intriguing process or event that has been found in one of the OOI data streams by the team that's working at Rutgers, and is believed to be worthy of study by educators. And if you are interested in more information about Ocean Data Labs, I urge you to seek out their site online. It's a great site and a great program, like I said. The next question is, how often are the ocean observatories visited? We have refurbishment cycles and deployment and recovery cycles. The regional cable array is visited once per year, usually in the summer or early fall. And selected instruments and infrastructure are traded. Not everything is traded every single year, but all of the instruments and all of the infrastructure is on a schedule for maintenance. And so that's done once a year at that site. The global arrays in deep water at full ocean depth are also visited just once per year. And those are turned in their entirety. And what happens with those is a ship goes out with a new copy of all the global instrumentation at the deep sites and thousands of meters. Usually the new instrumentation is deployed the old instrumentation is then recovered when there's room on the fantail for all of the equipment. And that equipment is brought back home and then refurbished for the next cycle. And at the global arrays, that's done once per year. At the coastal arrays, because of biofouling and other issues, those are turned twice per year, usually once in the spring and once at the fall for the Endurance and Pioneer arrays. And again, the full suite of instrumentation is turned. The gliders are turned more often than that using ships of opportunity. Okay, the next question is, are there collaboration efforts with non-OOI entities? And the answer to that is absolutely yes. We've made a concerted effort to interact with a lot of other programs. We have pretty close collaboration with the NOAA program I use, the Integrated Ocean Observing System, which has a complementary effort to ours. It's not science, but driven by applications. There's a lot of overlap. And we do interact with them. The specific question had to do with expansion capabilities. And in that regard, the non-OOI entities include the Office of Naval Research, who are using OOI assets and complementing them at the Pioneer Array to conduct a combined acoustics and physical oceanography experiment. That's the one with which I'm most familiar. And I know that on the Regional Cable Array, there are several programs that make use of the cable assets for work either funded by or spearheaded by other agencies. And a partial list includes the Office of Naval Research, also NASA, other NSF programs, and some international programs as well. Okay, can I add my own instrument to the Pioneer Array? And the answer to that is yes, and there is a procedure that needs to be gone through, and you can find it by going to the OOI website, or if you can't find it, you can email the help desk and ask for information. There's a process we need to go through for adding instrumentation. There's some advanced planning that's required, also some permissions that are required in terms of data and so on, power, et cetera. And so if you're interested in adding instrumentation to the Pioneer Array or any other, I strongly encourage you to read about the array on the website and then contact the program. We try to make it easy on the external investigators because we want this to happen. So please contact us with questions and ideas. All right, how has the instrumentation evolved over the short duration of the project so far? What's proven most useful and durable? What was proposed that hasn't been used? Okay, I don't have an exhaustive list, but I believe the instrumentation was established early in the program during planning phases, and I don't believe that large evolutions have happened over the life of the program. There is a tech refresh program that we have ongoing that's looking at the performance of instruments and thinking about how instruments could and should be changed to improve the overall scientific performance of the array. This is a challenging program because of the interdisciplinary instrumentation. Some of the instrumentation is very reliable and works well, workhorse types instruments, CTD, ADCPs, et cetera. Some of the sensors are optical and they're subject to biofouling, and the program works to mitigate that by recovering on sufficient intervals and also developing techniques to mitigate biofouling. So that there's sort of a range of what's proven useful and durable, ranging from very useful and very durable to some that requires more attention. And the question was asked, what was proposed that hasn't been used? There are two elements that I'm aware of. Originally, there was a concept for autonomous underwater vehicle docking that was developed and considered not to have the maturity that was needed to support this program for the lifetime conceived. So that was one element that was not included. Instead, autonomous underwater vehicles are deployed during shipboard operations, during deployment and recovery at the Pioneer Array. Okay, next question is, why were the Southern Hemisphere platforms discontinued? And the answer to that is that there were cost constraints. There's a lot of history, but the National Science Foundation has to balance infrastructure costs and the amount of funding that is available to support the scientific research that the infrastructure is supposed to enable. And so there's a constant tension between those two components, infrastructure and science. And NSF had a review headed by the National Academies of Sciences several years ago to look at this issue. And there were all of the NSF infrastructure programs were examined. And during that program, the recommendation was made that because of funding limitations, the Southern Hemisphere sites should be discontinued. And that entered our planning when we entered this phase of the program in 2018, and those two platforms have been discontinued. We still continue to hear from some members of the community that they would love to see those back again. And hopefully someday we'll find a way to restore them. And could the OOI designs be used to build other observatories outside the US? Who should I contact? Really interesting question. I think the answer is probably yes, or at least a qualified yes. And if you're interested in that particular thing, please contact the organization. Probably the easiest avenue is the help desk. Okay. I think I've answered all of the questions that have been asked, or at least the ones I see online. And I thank everyone again for attending this webinar. And I hope all of you find a way to use OOI data and find a way to participate in using OOI infrastructure. Thank you very much.